pleased and excited and appreciative of that. So we're Paradigm4, but as you saw from the guest password, we abbreviate ourselves and call ourselves P4. And the office space, we run a sort of hybrid thing here, so we're in 3 days a week. Tuesday's not one of our in the company days, which is why you don't see like hordes of people here. We're usually in Monday, Wednesdays, and Thursdays. But we're happy to have you here. And with that, I'll turn it over to Philippe.
Yes. So thank you for accepting to organize and host this session. It's a pleasure for us because we don't know Paradigm4, we don't know FlexFS. The reason why when I identify a company and the product, I say, you have something interesting to say, so we need to meet them.
And then we'll introduce the primary people on our side. My name's Marilyn. I'm the CEO and co-founder of P4. And the first person that you should know on the top of the screen there is Gary Planthaber. He's the one, Philippe, that set this whole thing up with you. Gary is P4's CTO, our Chief Technical Officer. He's also the inventor of FlexFS, so he's going to have a lot to share with you about the technology. Also with me on the call, I don't see Dave Clock's video. Dave, did you go off video? There you are. Dave Clock is based in Colorado, and he is heading up our business development. Andy, this is Andy Cosgrove. He's our Chief Revenue Officer.
Nice to meet you.
And our other presenter today is David Freund, F-R-E-U-N-D. And David is our technical sales, partner with Dave Clock and with Gary Planthaber. So with that, I'm going to ask Gary to kick us off.
Yeah, greetings, everybody. By the way, Marilyn, the camera's not facing the group, so I can't see anybody except you right now. I don't know if that matters, but it would be easier. Hey, everybody. And so pleasure to have you guys there, even though I'm not there. Just missed me by a couple of weeks, but I'm currently in Europe, so I guess we did a continent swap. But thank you for your interest in FlexFS, and hopefully we'll get all your questions answered today. A little bit of history about FlexFS, because I know you guys were interested in that, and why did Paradigm4 build it, right? And what kind of advantages it provides. A lot of those technical details will come out in the presentation, so I won't go into them now. A little bit of the background will come out, but I'll give you a little bit of a higher level picture. So Paradigm4 predominantly has been focused on solving data problems, right? And we've focused a lot on solving those data problems, both analytics, storage, and so on for the life sciences industry, because they have a significant amount of data, and we have now a significant amount of staffing with bioinformatics people, as well as history and experience with dealing with very large life science data sets like population scale genomics, such as the UK Biobank and so on. There could be quite a lot of data to handle there. And cloud economics, as you know, are quite different than on-prem economics. And we needed a way to do really scalable computing for some of the analysis that needed to be done for our large, life sciences customers. And that could include clusters, approaching hundreds, if not thousands of large compute nodes that have to process, potentially tens to hundreds of terabytes of data, all at the same time. So in order to scale those compute clusters so you can get to the answers quicker, you need a data fabric that can deliver very high throughput. And at the time that we started doing this, there was quite a big race going on among licensees of the UK Biobank data. They paid quite a large sum of money for exclusive access to that data for a period of, I believe it was 1 year. And so they wanted to mine through that massive data set as quickly as they could. And the way they do it is through massive parallel compute in the cloud predominantly. So we needed a way to get the data to those tools running on all those servers concurrently, predominantly using POSIX and files. So we needed to have a solution to that. But a lot of these files were quite large, at least a few hundred gigabytes. And to have to download a whole reference file of that size on hundreds of workers concurrently would put a lot of strain on a data fabric, or take a lot of time. So we started looking for solutions to that for our customers, and we didn't actually find a lot, right? Short of like FSX for Lustre in AWS, for example, that can scale, but at great expense. And we knew that our customers didn't have the budget, weren't willing to spend the money on that at that scale. So what we ended up doing is trying to find workarounds, and we tried everything. And ultimately, though, we realized we needed a POSIX file system, a network file system that ran the POSIX interface, but simultaneously be able to deliver potentially tens or hundreds of gigabytes per second to the cluster as it was running its analysis. We did find some solutions out there that may have been able to scale as they were also built on S3, but their pricing models or other details of their implementation prevented us from using them within such a strictly regulated industry. And with this particular kind of data, like genomics data, for example, which is very sensitive. So we had to cross off some of the vendors. And by the time we were done, we really didn't find anything in the open source community that could get it done. And anything that was like not in the open source community was priced too high still for the budgets that we were trying to hit. So we just decided to build the solution that our customers needed, and that's what our company does. You know, if we run into an insurmountable problem that we can't cover economically with open source or with a vendor who has pricing terms that are agreeable to us and our customers, then we'll build it if we need to get through the problem. So FlexFS was born from that. And what we realized after a little while is, though, that like FlexFS is a file system, right? It doesn't care what kind of data is in it. And there are other industries and other customers that don't need the rest of our stack who could benefit from using FlexFS. So we decided to sort of create, you know, a branding around the product itself and try to sell it to other customers. And that's what we've been doing. And since then, we've made quite a lot of strides in the development and the performance and so on of FlexFS. And we've also recently released a community edition that gives people like license-free 5 terabytes of storage against their own bucket, their own S3 bucket. It's the exact same system as our full enterprise version, including the metadata server, but it does not have support for proxy groups, which David will explain in the presentation. With that, I think what I'll do is hand it over to David so that he can give you guys the slide deck. And then what we can do is open it up to questions and cover anything that I didn't cover now, if that's okay with you guys.
Yeah, so first question. So you mentioned you study the competition, if I understand correctly. You study things like Nasuni, Panzura, all the gateways existing, and some of them are based, let's say Nasuni is also a Boston-based company.
Yeah.
Is it correct?
We didn't evaluate everybody. And remember, when we started this out also, it was several years ago. It was probably like 5 or 6 years ago. So what may be available and competitive today may not have been back then, but we didn't actually try Nasuni back then.
Avir.
But we did, I'm sorry?
Avir system?
Avia?
Avir.
Avere.
Aviri.
Yeah.
Avere.
No, so I didn't try that one either. We didn't do an exhaustive search across everything, but we were actually at the time looking for open source solutions or relatively inexpensive solutions. I don't know what those cost, but we didn't try everything at the time. I don't even know that name today, to be honest with you. But things we did try, we tried JuiceFS, we tried ObjectiveFS. We were looking at the time for S3 backed solutions. We tried S3 Backer, which was not technically a file system, but can be quite scalable nevertheless, even though it's like sequential IO performance isn't particularly great. We managed to get by with that until we finished FlexFS. We tried the cloud file systems themselves, like, you know, especially within Amazon. So we tried, you know, EFS and FSX for Lustre and so on. So, you know, we did evaluate quite many technologies. We also tried things like S3FS and all these other things that were out there, Goofies or whatever, however it's pronounced. Quite many of these sort of non-traditional, non-centralized file systems. We tried all that first, and we also evaluated any that had pricing models to see what it would cost our customers. And there weren't, there weren't too many gateways. But there was the Amazon gateway that was available. I think it's called, I forget what it's called, but not the S3 files, but the one that they use to move things from on-prem to the cloud. You can also use it within the cloud, but they also didn't have the I forget what it's called now. The S3, file system that Amazon created themselves in Rust, which, is not a network file system. In fact, many of the things we tried were not network file systems, and they didn't have full POSIX support. They were sort of POSIX-ish. And so you run into all kinds of problems as some tools expect certain features of POSIX that may not have been implemented by some of those file systems. So we didn't find any open source solutions at the time that were S3 backed that could deliver enough throughput. Anything that's not S3 backed has an inherent bottleneck because you have to run a cluster of servers and route all that throughput through it. And that can get quite expensive just from a hardware perspective. So we were trying to avoid anything that routed data through a central potential choke point at the time. There are applications for that we allow FlexFS to support, but initially, FlexFS was meant to be a client direct to S3 solution, so we don't have potential bottlenecking in the infrastructure. Otherwise, it'd be very hard to move hundreds of gigabytes per second or more without spending a lot on hardware.
Okay. Any other questions on that? So, as Gary mentioned, our own clients, were facing this challenge, and everyone's now focused on AI, and a lot of the attention's been on the compute complex and what all is happening there. But the foundation that all this is based on, we see having cracks in it. And for the most part, the workloads, the applications that are actually trying to do work speak files and directories. And more often than not, file systems end up forming the hot path for data. And that's not changing. Meanwhile, you've got these really compelling economics of object storage, but object storage comes with high latency both in metadata and file I/O. And that's not changing either. And in high performance computing, those needs tend to demand object storage be used in less active tiers. And there are no public percentage numbers on that split. It's very workload specific. But in any event, folks end up trying, the ones that are trying to actually get useful work done and actually trying to train models and get inferences running, end up having to work on getting the plumbing right. And if they don't get it right, that becomes very expensive. You're wasting money and precious time, which again translates to money. And so, especially in the cloud. So our customers were facing this challenge, and frankly, we agreed that it just shouldn't be this hard. Okay. And as Gary said, we had to find a solution for them. And, again, hyperscale cloud, great economics. They have great elasticity, seemingly endless throughput and endless capacity. But again, not a file interface. Cloud file systems, on the other hand, like EFS or Azure files, et cetera, have that wonderful interface, nice low latency, but throughput, frequently you hit a ceiling very, very quickly. And we found that ourselves. What we wanted, what we really needed, was the best of both worlds. And so some folks said, well, that's easy. Tell you what, why don't we just store all our data in object storage, and then when we need to do the compute, we'll transfer all the files into local NVMe drives, do all our calculations and everything, upload the results back into object storage, rinse and repeat. And here's the thing. It's a simple, straightforward answer, but you're waiting for those file transfers. Okay, so you've got these expensive CPUs, or even worse, GPU servers, spinning idle waiting for file transfers, burning cache. And as Gary mentioned, if you have a couple hundred or a couple thousand of your favorite nodes all doing this simultaneously, that back end is going to suffer. And frankly, S3 wasn't designed for that. And so Gary mentioned we looked into what was available in the marketplace, open source, commercial, and so on. And a de facto standard out there, Lustre, was born in the data center, the physical data center. The idea being, if you have this high performance cluster doing massively parallel accesses to storage, any single storage server just collapses under that barrage, under that tremendous workload. So we need to parallelize access to storage as well. So how many people here are familiar with the Lustre file system? Okay. So, very, very simply, scatter the data across multiple servers, attach disk on those servers. Now you've got all this ability to do parallel access from a lot of parallel compute. So how do you do that in the cloud? Lift and shift that entire design into EC2 instances or on Oracle or Google or whatever, okay? You configure them the same way. You've got EC2 instances, for example, with direct attached storage. You manage it the same way, and it's not elastic. If you need more capacity, you allocate more servers with more disk attached. And oh, by the way, now you've actually got a direct hard link between the amount of throughput capacity you have and the amount of storage capacity that you have. And so if you need a lot of throughput because you're doing very, very heavy compute, a lot of accesses, but not to a tremendous store of data, you can waste a lot of space with that Lustre configuration. And so you're doing all of this, you're completely shifting aside all the person centuries that the hyperscalers like Amazon, Google, Microsoft put into building performant, high-scale storage, okay? So, all right, we need to integrate with that, fine. We'll bolt it on. We'll use it as a kind of an archive tier for your colder data, and that's it. And while I'll concede Amazon did something recently to try to address that, we'll talk more about that later. But at the end of the day, they satisfied most of the needs where we wanted it all, but not really the cost, both operationally and frankly just the cost of the storage itself. Even with the managed storage offers, managed service rather, offerings from Amazon, all three of the biggies have it, so that you don't have to actually install all this software yourself. You're still doing the capacity planning, you're still doing the monitoring, and oh, by the way, if you want to shrink a volume, you're in for a world of hurt. And if you guys are familiar with Lustre, you already know what I'm talking about. So our approach was to come at it from the complete opposite direction. Actually leverage the strengths that hyperscale object storage brings, but bolster its weaknesses. So address the issue around the latency, speed up that metadata I/O, speed up the file I/O, and do it in a sort of a set it and forget it design center, so that you're not doing all that management. Just, it runs, it's elastic, and do it at a price performance that can't be beat, just basically an increment above what you would pay just for native object storage. So this is the way we can have it all. So, all right, so the next question obviously is just how did we do that? All right, so what we do, similar to Lustre, if you're familiar, you take a file, break it up into chunks, and instead of spraying it across multiple servers and disks, we give each chunk an object ID, we store that, and let the hyperscaler figure out how to get parallel access to all that, okay? And so you've got, on the compute instances, we have a mount client, okay? And that can communicate directly, storing all those chunks into the object store and retrieving them. Wait a minute, what about all that latency you were talking about, David? Well, we address that two ways. For the metadata, we actually solve the problem by redefining it. When we move the metadata concern into FlexFS's own persistent, low latency metadata service. And then for file I/O, when latency matters, we have an optional proxy group. It's essentially a write-back cache. We use the phrase proxy group to describe it because it's actually designed like a CDN, okay? And we'll talk a little bit later about why that's important. So now what's interesting about this cache, the write-back cache, is you can not only have it on and off, but you can also have fractional caching. Let's say you have a volume with a whole bunch of really large files, you're reading and writing them sequentially. Latency is not really a concern, so just the direct path to object storage is fine, okay? But on that same volume, you may have a whole bunch of really small files, you're doing a lot of random I/O to them, but you know that they're about 100 blocks or smaller. So what you can do is tell the proxy group, okay, I want you to cache the first 100 blocks of each file on this specific volume. For block 101 through N, go direct. And the mount clients are smart. They know about this. They know where to go. They don't have to talk to anything else on the network to figure out where they need to get their data from. So again, the idea, the design was centered around efficiency, trying to do as little work as possible to just get data into the hands of the CPUs and the GPUs.
Can we say that one file is chunked in different segments, and each segment is stored as an object on an object store on the back end?
That's correct.
Okay.
So it is not a one-to-one mapping of files to objects. It's a 1 to N,
Okay.
right? So, and because of that, we've actually increased the parallelism of the access to all that data in that file. And we've actually increased the efficiency of doing byte range I/O because we're not having to go plowing through large objects if that's what you're dealing with. So that one-to-N mapping is actually very useful for us.
But from the compute instance, so you have a driver to just have file access.
Yes, it's actually a fuse file system.
It's a fuse file system.
Mm-hmm.
Okay, and then when you are on line number 2, so you are writing the file, right?
Yes.
You are writing the file, so you just send the file to an object store. It's not even with actually you make the translation between file and object at the compute instance, and you just post.
And we're basically, so we treat that object storage as a block server. Okay. And so we're writing pieces of the file to it. If we're caching, we'll actually go through this mechanism so that we'll get, a write back cache. So, when it gets into the cache here, the epoxy server will send back a response saying, yep, that's complete. And then we'll actually batch up the IOs and send them those blocks into the object store.
Okay, I see.
Okay.
On the metadata aspect,
Mm-hmm.
I see the image there is 3 on this image. There are 3 on this image.
Yeah.
Does it mean you shard the metadata database, or they are all active and have a copy of the full database?
Gary, can you answer that one? Did you hear that?
I didn't actually hear it very clearly.
Can you repeat?
Oh, he's asking why there are 3 metadata server blocks.
Well,
and
the question is if there are 3 of them that are
Yeah, if
active.
you
Go
could
ahead.
repeat your question right there.
Yeah. So my question was, I see on this slide 3 metadata server. Okay, there is 3 rectangles.
Rectangles.
Yeah. Does it mean each of them is active with a full database image, or only 1/3 if you shard the metadata database? How do you organize this?
Yeah. So right now we don't do sharding. So what this means is one of 2 things. We have an HA configuration, so high availability configuration. So it could mean just replicas for uptime and durability if you're using HA. It could also mean another thing, which is the way FlexFS works is that each metadata server is responsible for 1 or more FlexFS volumes or namespaces. But you can have as many metadata servers as you want. So that's one way of partitioning or sharding but it would never split a single volumes metadata across those servers unless it was in the HA configuration, and that would just be mirroring or replicas. What it means, though, is that you can have as many metadata servers as you want, each with a subset of your total namespaces or volumes. So you could have like 5 volumes on each, right? So you'd have 15 in this org if we're not using HA.
But the difference with some file system like Lustre, for instance, when you are writing your data, you are not asking the FlexFS metadata where to write. You are sending the blocks, and then the Flex metadata knows where the blocks have been recorded, right?
Yeah, so what happens is first the FlexFS clients, they write the data, right? They're getting writes, and then there's 2 possibilities. One is that you write the full file and then you flush or fsync or close it. And And at that moment in time, all the metadata would get flushed to the metadata server, and it would have just already been written to the buckets. So we know that the files blocks have already durably been stored in object storage. So now we're just updating our metadata record. Alternatively, there are a couple other mechanisms. So you can fsync at any point, right? So you can be writing a large file and perform regular fsyncs, and that will cause metadata to get flushed to match what's been already stored in the object storage. It also causes any caches to be flushed as well. But basically what happens is the metadata gets updated like, a fraction of a millisecond, right? After the fsync, the flush, or the close has occurred.
Okay.
And then that creates, a notification that goes out to all other FlexFS clients to let them know that there's an invalidation of that inode.
About data redundancy, do you rely on the erasure coding replication of the object storage itself, or do you have some policies, let's say, managed at the metadata server, but operated at the client level in order to send, let's say, multiple copies or things like that to different targets?
Multiple, you mean for the block data?
Yeah, so let's say I write, the client write a file. Do you rely on the object storage backend redundancy with erasure coding, etc., in order to protect data?
Yeah.
Or do you also add a layer to, let's say, send another copy to another target?
Yeah, for backup and redundancy.
Yeah, no, we don't do that. See, what you can do though is you can set policies on your buckets. So we built this to be cloud native. So almost every cloud provider has bucket policies where you can either replicate to another bucket or you can keep versions for a certain period of time or whatever else. We didn't try to reinvent that in the file system. We wanted to leverage the capability of the object storage systems. So for example, the erasure coding that you're talking about, you don't technically have to do that. Like Flex can target any backends. It's just that it will get whatever durability and performance guarantees that the backends give you. So we did architect it to sort of hijack whatever mechanism is already in place from the back end, the block store, and we can target different ones. But all major object storage systems have erasure coding and have a variety of retention policies and stuff like that, and replication policies. So we just rely on the underlying vendor's object storage capabilities for now.
Yeah, and they're asserting 11.9's data durability. So, I mean, how do you compete with that, right? A couple other points to note. This object storage, this backend can actually be any key value store. It does not need to be the S3 API, for example. Okay. And another thing to note is the caching is actually multi-level. In the compute client, we'll actually leverage both the RAM and local NVMe. And in the proxy servers, we also leverage both RAM and directly attached NVMe. So there's multiple levels all intelligently being managed here. So it's not just the thing in the network. All right, so another thing to note is that you can run all this in a single region, in a single cloud, as you would expect, but you can also go to multiple regions, multiple clouds, okay, multiple on-prem sites, or any hybrid combination of cloud and on-prem. And each volume has its backing store in one of these locations. And you can place proxy servers in every location that's also accessing that volume. So that while that first read might be a little slow if it's on a different cloud, but once the data is cached, you've got electrically close behavior, performance levels. And so you've got that local-like performance everywhere. Excuse me. And the proxy service, like I mentioned before, is designed like a CDN. So Mount clients actually automatically select the best performing proxy server to cache, that's available to cache that volume, and use that one. You can also have the Flex services themselves co-resident on the compute node with the application layer. So you can, in a converged configuration. And in collaboration with our friends at Oracle, we actually validated this config And with it, we saw near local NVMe levels of performance. And we actually have a link here, and you guys, I think, already have copies of the deck, that actually shows what that was like, even though the data is still being persisted in object storage. You're still getting that high performance parallel file system behavior. And this thing has, I think we've implied, has been running in production at several lighthouse accounts and maybe some lesser known ones in production, managing petabytes of data, hundreds of millions of files. Yeah, question?
For this case studies, does it mean you replace something, or is it a new project?
Replaced. Gary, you can comment on that because you did the.
Yeah, I mean, the answer is both. It depends on the customer. But what typically happens is either, well, there have been three things that have happened. One is that FlexFS goes with our life science product stack because we need it for the really elastic, compute that still goes on at many of our customers. So what happens is their IT organization and/or their project teams will evaluate FlexFS for that first, but that gives them familiarity with the file system and its performance characteristics, and also just how easy it is to manage and stuff like that. And then what typically will happen is they'll say, oh, like there's a new project starting up, maybe we can use FlexFS for this too, or hey, we've been having problems with one of these other systems we've been using, maybe we can replace it with FlexFS. So all of those have happened. On occasion, we've actually had an evaluation for an entirely new project at a new customer. So they would say, hey, like we've heard of FlexFS, or we've met you guys once or twice at different conferences or so on. And they say, hey, let's evaluate FlexFS. Let's do a POC for this particular project we're starting to do. So that's happened a few times. We've had greenfield customers working on greenfield, projects as well. So the answer is pretty much all of those.
Okay, so why don't we talk about some of the use cases that we've seen there in production. And one of them is a common storage fabric and scratch space. So for example, sharing data between our studio sessions and HPC clusters in a single unified namespace. We've got the R&D data commons, a place for researchers to be able to collaborate, share data, including access from multiple HPC clusters, and doing that without moving or copying data around. And then once you start having copies propagate, you start getting capacity bloat and so on. Not a lot of fun. We'll actually say more about that particular use case in a minute. But from the list, you can see some themes emerging here. Excuse me, combinations of data staging and prep, scratch space, intermediate result storage, human collaboration, HPC cluster access, all without needing the time and expense to move or copy data around. So let's talk about that research data commons use case. So again, global, central repository for clinical and other research data. The existing system that this replaced was basically hand-built and hard to manage, very unwieldy. So they were looking at essentially two things. They were looking at us and a pure Amazon solution. And so it was a combination of S3, EFS, EBS, Lustre, and so on. And they ended up choosing us. We'll go into more of that in the next slide as to why. But so they're storing over a petabyte of data, over 160 million files and folders. And last year alone, they saved over $1.4 million as opposed to what it would cost with the AWS solution. So basically, just a little over a third of the cost of what the competing solution would have been.
But at the end, it's running also in AWS. It's not running on.
It's still running on AWS, but not using AWS's storage solutions. Okay.
Other than S3.
Yes, correct. So, and I'm sure you've seen many times the level of analysis that goes into trying to use these storage systems in an optimal way. And in this case, the combination that I was talking about, EFS, Lustre, and so on. And you can see some of the numbers of, all the pricing and everything. Here's the thing, even with all this analysis, this doesn't take into account the expense of actually managing the data in that kind of an environment with all these different tiers of storage, okay? And needing to move data between hot and warm and cold and deciding when you need to do that and, oh, we need it now, and you're transferring data around. So there's an operational cost to that. Another important aspect is FSX for Lustre being inelastic, okay? So, with those direct attached disks, you have that linkage between how many servers you have deployed and how much throughput you have. And so, you have to have capacity to meet your throughput needs, regardless of whether or not you're actually going to use all that storage space. Now, it's worth noting, and I'm sure many of you are aware of this, Amazon did respond to the outcry about that. And so they invented intelligent tiering, which I use air quotes around, making FSX for Lustre capacity mostly elastic. They claim it's fully elastic. Here's the thing. What's really going on is they don't charge for the unused storage, okay? And they still charge for the throughput that you need to allocate. So you now tell it how much throughput you need. We'll charge you for that. Oh, by the way, now we're also going to charge you for SSD read caching. So, and you can choose whether or not we figure that out, we being Amazon, okay? And we'll just charge accordingly, or you can decide how much you need, or just decide, you don't need that, okay? They're still getting paid quite a bit.
And there was another hidden benefit as well, which is because they had a provision system, every time they, hit the max and had to take it down and then provide larger capacity, they had scientists that were down sometimes for 24, 48 hours.
Well, to be clear, you can expand a Lustre volume non-disruptively, okay? You can't shrink it, okay? Unless you use this intelligent tiering thing. Oh, by the way, you can't convert a standard Lustre volume to intelligent tiering. You have to migrate that. And it's just moving stuff from Amazon's versions of hot, cold, warm, storage and so on. So shrinking a Lustre volume, a standard Lustre volume means you stop production, create a smaller volume, copy the data over, make sure your applications still run correctly in the new location, okay? Start production, everything's fine. Now I delete the old larger volume. That's very cumbersome, and as Marilyn said, everyone's waiting. You get no production done while you're waiting for all that, okay? So FlexFS, on the other hand, easily handles all of this in a single unified space and at a fraction of the cost. It saved them over the course of the last 3.5 years over $3 million. And like I said before, over 1.4 million just in 2025 alone, and no migrating data all over the place. We charge for the data stored, and by that I mean that quite literally. We're not charging for, metadata overhead. We're not charging for rounding to the next block. Okay, it's literally the bytes you store. Okay, and of course you do pay for the S3 backing store, but then that's it. Other advantages that clients like this have taken advantage of is, built-in time travel or, point-in-time recovery. And you remember we were talking about how when we store blocks into the object store, we give each one a unique object ID. Well, if an application goes to overwrite that block, we don't overwrite the object. We allocate a new one, write the new constants to that one, and Flex remembers that old one and the metadata associated with it for a settable retention period. So you now have, storage vendors like ones I've worked at, at EMC or NetApp, we would have called that continuous data protection, right? Okay, so essentially a revector on write kind of a scheme. And so, so for every I/O, every metadata change, we're recording that and storing that as immutable data until your retention period expires. So that actually gives you provenance, data governance capabilities to be able to go back or even recover from, some rogue entity that hacked your system, or disgruntled employee, or rogue AI agent, what have you. You can actually go back in time and just recover. So one of the things you can do is you can mount a read-only copy of that volume, non-destructively. You can still be running production, and then go and recover, or even just examine as much data as you need to, and then just dismiss it, and it just goes back to where it was. Meanwhile, you're still running production. You haven't stopped a thing. So some other features worth noting. The top two are actually relatively new. We released those capabilities this year. What we have had pretty much all along are non-disruptive updates. So the mount clients themselves, you can continue doing I/O, and using some of the capabilities that the Fuse subsystem gives us, we can actually swap, what code section is doing the work completely non-disruptively. So, no unmounts, no stopping the application, no data, loss or interruption. And the server components running in the network or in a converged config, you can update those, restart them, and the only thing that happens from the client's perspective, from the compute nodes, is I/O may pause for less than a second and then just resume. Again, no impact to the data or anything else in the operation. And we do have a CSI, native CSI driver, for Kubernetes, because any serious entity nowadays needs that. This year we added deduplication. I think you all know what that means. And we validate duplicate files in the manner you would expect. Not only checksum, but then we'll actually do byte for byte verification before we'll make any changes. And even then, you can actually just ask it first, what would this do? How much can you reclaim? Don't do it yet. Okay, now make the change. So you can actually make that decision as a data manager. And then the find utility, I think the Unix find we're all familiar with. It traverses the file system to go and find the data of interest. Here's the thing, that takes time. We've all seen it, okay? We have a separate metadata service already. So how about we just create a find utility that talks directly to the metadata service and just say, hey, find all this stuff for me, and get an answer like that at orders of magnitude faster. So
exactly,
that was a customer delighter.
Like the Unix command, so you can have the date. It's not a find for object storage where you can have extra metadata in the to ask in the command. For instance, it's only POSIX.
Yeah, you can. Yeah, there's a lot of. I think we've got a pointer later. You can actually go to our website. We have all our online documentation there. You can actually see exactly how we do all the parameters. There's a lot of parameters you can give it. Lots of different kinds of metadata and so on. Okay. And one of the things that we do support, is extended attributes. So if you want to store just even user-defined metadata, you can store it like you can with an object store. And we do have some clients that actually depend on that. So they store extra metadata. It could be any, things about an image and how it was created and what the equipment was and so on, right? And so we provide all of that. We've got clients that use that for their data governance and so on, provenance, especially in a clinical environment.
Mm-hmm. Just to be clear, it's not a drop-in replacement for the Linux find community utility. It's similar. It has a lot of the same basic filters that find has, but it also has some that are kind of FlexFS specific. So we have, for example, the ability to do a time, like, how long has it been since a file has been accessed? That can affect our pricing, for example, with some, when we negotiate that with our customer. And the find utility can tell you how much, like, each file is costing you, like, per unit time. It can, and of course, it does all the other things you would expect, like filter on file name, filter on the timestamps, and so on, types of files, permissions, and everything else. But we have a bunch of other utilities too that are not on this slide. But again, you can find that on docs.flexfs.io. But it's The idea here is to bypass the POSIX API because the POSIX API plus a network leads to a lot of round trips and a lot of very microscopic sort of like latency sensitive operations that cause the results on very large volumes to take a long time. And since we have customers with hundreds of millions of files and petabytes of data, like we needed something faster than going through the POSIX API, especially with a Fuse client, right? So we wanted to bypass it altogether and just speak directly to the metadata server.
Okay. And one more question regarding deduplication. So between the errors you're coding you have for storage, object storage, and the deduplication you have on the contrary to reduce the size of the data. So at the end, what is the size of what you store compared to the useful data you are storing? I'm not sure I'm clear. But,
so that's a function of, so this is at a file level. So we're not deduplicating individual file blocks or anything like that. Okay. So when we find that there are two files, one's named Marilyn and one's named David, but the contents are exactly the same, and then what we can do is then say, okay, tell you what, we're going to keep one copy of that. Then the thing named David is going to be just a hard link to the contents of the thing named Marilyn.
Yeah.
Okay. You're familiar with hard links in
yes.
Yeah. Okay.
In POSIX. In
POSIX,
Unix.
yeah. Yeah.
Okay. Okay, I see. But
one other point to answer what I think you were asking as well, which is that we didn't jump into this, but FlexFS storage optimizes its blocks, and it does that in two ways. One of them is trailing zero removal. So like if you only write like 4 bytes into a block that might be defined as 4 megabytes, you don't want to store a 4 megabyte object into object storage. So we first look for those like null bytes at the end of a block and remove them. And then we also do compression. And we support a handful of compression algorithms. Defaults to LZ4, but we also support things like Z standard and Snappy. Or you can turn off compression if you don't want to use it, but it still does the null byte removal at the end of the blocks. So in practice, what ends up happening is that if a file is compressible beyond its like raw form, then Flex will usually save you money on the object storage bill. So we typically see like pretty significant compression on things like textual data and stuff, and a little less so on like compressed images and certain types of files that have been already storage optimized.
The other thing worth noting is because the compression actually happens on the compute nodes. So it actually scales out very nicely. You're not doing something on the back end trying to handle all of that. And the packets actually flying over the network are now smaller. So you can actually get more data through a given size network pipe. So you can actually improve performance with compression. Another thing to note is that we also, of course, support encryption, and obviously at rest and in flight, but also end-to-end, where the keys are on the compute node and nothing else sees them. Okay, so it's completely opaque to us, to the hyperscalers, to anything in the network path. So you've got that capability, AES 256, compression. And all right, so anything else on that?
What about
Yeah.
locking?
Locking?
Locking on the client level between two clients who want to access the same file, etc.
Yeah, we do support Linux advisory locking. Yeah.
And just to be sure to understand, because your solution works very well with S3 from AWS in the cloud, but you can use it also on-prem. So you can use it with some other solution of object storage.
Correct, like say MinIO. Yep. Yes.
But my question is, so when you are using another solution of object storage, perhaps this solution also has deduplication, compression, lot of things about working with the data. So how do you manage their own function
No, we actually do the compression, the deduplication ourselves. Okay, we're not dependent on any of those, object storage providers. We're trying to treat them as much as dumb block storage as we can. Okay.
So it can be possible that it happens at the end. You compress twice. You compress and also the object storage system compress.
Yeah, but just to be clear, one of our compression options when you create a volume is none, so you can turn off compression. If you know for sure that your object storage solution is doing that and you don't want to do it twice, you can turn off the feature completely. Yeah. The second thing is the way deduplication works in FlexFS right now is it's a manual operation. It's not happening automatically behind the scenes as you're using the file system. It's a separate utility called dedupe.flexfs that identifies the duplicated content and then can optionally fix it using hard links. There are some reasons you may not want to do that, so it's something we do manually.
You can schedule it, of course, using cron or something, yeah.
So, but to answer your question, if you knew your backend storage system for the blocks already did either compression and or deduplication on its own, then you just don't have to run the deduplication on Flex because it's being handled by the backend system. And same with compression. Now, the only thing is there are some benefits to compressing in the client, as David mentioned earlier. And those benefits specifically are along the lines of reducing the traffic going over the network. So if you deduplicate at the object store, then you're sending the decompressed data over the wire, which means that you can't pump quite as much data across the pipe as you could if it were compressed.
Okay, and as I mentioned earlier, we only charge for the data stored. It's, we're just an incremental cost over what you're paying for the object storage. And so we're actually, in doing that, we're actually leveraging not only the starting point, but the slope of object storage. And, object storage has this kind of a slope from Amazon. It's also true on Google and Microsoft, Oracle Cloud Infrastructure, and then that particular hyperscaler's file thing, like EFS on Amazon, tends to have a steeper curve or a steeper slope like this. And even more so for managed Lustre implementations, which all the major clouds also offer. Okay, and here's the thing. Let's say you add, because your workload demands it, you need additional cache, and so you actually add another compute instance that has our caching software on it. We're not charging more for that cache capacity ourselves. Okay, you're only paying for, as a customer, you're only paying for that additional EC2 instance on Amazon. So what you do is you just sort of raise the floor, the slope remains the same, okay? It's a fixed cost. So if you keep increasing your capacity, but your workload isn't increasing, okay, you don't have to pay for additional cache and everything, and as the more you store, the more money you're actually saving. This is something that, our top 5 pharma client that we were talking about actually, saw. The more they put into Flex, the more money they were actually saving.
So what you're saying is you don't need additional cache for additional cache.
For additional capacity, right?
Okay.
You don't need, for additional, I get it. Very good.
Penny finally dropped. The cache came in.
So do I have to pay you royalties if I steal that?
Please. Yes, that would be great. Yes. No.
Okay. All right, so so we save money not just on the compute costs, anywhere from 1/2 to 1/5 of what you would spend on the traditional cloud storage, if you will, but we also save on your compute costs because we're delivering data faster, so less idle time. You get more actual work done per unit of CPU money that you're spending. You can avoid user downtime if you're trying to deal with an inelastic storage scheme. Using us mitigates that, and just lower operational overhead just in general. So being in the data arena, we naturally realize there are a lot of use cases outside of life sciences, and and things that we've been looking at recently and have been in conversations with clients and prospects and SIs industry analysts, even other technology vendors about these. Data lakehouse acceleration. We'll go into each of these individually next. Coupled architecture, DBMS modernization, AI, training and inference acceleration, and of course agentic, use cases. And in our conversations so far, some of the verticals that have come up, and we'd like some of your thoughts on this, in a bit, is we've talked about Earth observation and financial services and regulation, so some government stuff in there, oil and gas, IoT data in manufacturing, and so on have come up. So let's go into each of these a bit. So modern data lake houses, often rely on Apache Spark and Spark compatible, engines to do the querying of Parquet files, basically, Parquet house data. And in Cloud Object Store is a common pattern. And as we said before, great scale, low cost capacity, but introducing latency, and it can affect things like file discovery, doing query planning, selective reads. It all impacts that, and it can substantially limit, the end-to-end query performance. And so Flex addresses this bottleneck, by you place our file system in between the Spark, analysis and the object store, and take advantage of making that planning phase go from 30 to 60 seconds to just under a second. So get some throughput saturation, because we can increase the parallelism and of course elasticity. And we actually did some benchmark runs using the TPC8 suite, TPCH, how you doing? Suite of queries at a scale factor of 100. And what we found was, Spark, plus gluten on FlexFS with caching enabled, we got through all the 22 queries in 175.8 seconds, compared with 1191 seconds for just the Spark on S3 baseline. And it's an almost 7 times performance improvement. So the central conclusion is pretty straightforward here. Data lakehouse performance is shaped not only by the execution engine, but also by the storage that's beneath it. And when object storage latency and metadata overhead are reduced, Spark family engines actually complete Parquet workloads much, much faster. And native accelerators such as gluten benefit the most. Now, and that same performance benefit applies to Spark alternatives such as Presto that support POSIX file systems. Now, Comet, you may have noticed this ugly thing in the center here. Comet kind of forms a cautionary tale. It is a signal about when you're doing lakehouse acceleration. On S3, adding Comet to Spark improves substantially over vanilla Spark, okay? But worse on a non-cached FlexFS. And yet, 4 times better when you use FlexFS with caching. So digging into this, what was highly suggested, looking at the data, was that some accelerators like Comet are very sensitive to the shape of the IOs and how serial they are versus parallel. And Comet does quite a bit of serialization. And so in lakehouse environments, storage is not just a bandwidth question anymore. It's also a question of whether the storage layer tolerates, or better yet, actually compensates for a suboptimal access pattern.
There's one other thing, David, which is that a lot of these engines are S3 native, right? Which means that they've optimized all the code paths for object storage, right? Mm-hmm. And they have completely different behavior than their POSIX support, which was like an afterthought, and a lot of them didn't put a lot of time into testing those code paths. Some of them are just for debugging locally or doing local development. So just bear in mind that some engines handle POSIX better than others, but almost all of them are written with S3 in mind first. So Comet, we suspect Comet actually doesn't have a very optimized POSIX implementation.
Yeah, that's fair. And so the bottom line from our perspective is that the right storage can actually correct or at least soften engine level inefficiencies. And so you can actually think of a proxy tier as not merely a cache, but a compatibility and optimization layer for less favorable I/O behavior. So coupled architecture modernization for DBMSs. The idea here is to upgrade these DBMS clusters with direct attached disks, such as MPP data warehouses, graph and vector databases, and to use elastic high throughput storage served by FlexFS instead. And so those clusters rely on very strict POSIX semantics as well as both low latency and high throughput I/O. And what we can do is decouple the compute from the storage and enabling each to grow independently, and that can translate to a smaller compute cluster, completely separate from how much capacity you need, and thus lower your costs. Even better, you can do all this without any code changes, okay? Because FlexFS presents what looks like a local disk with a file system mounted on it. So as we've already discussed, the caching can absorb the predictably random I/O bursts that can come with these systems and provide near local NVMe performance using a converged config. And as I mentioned earlier, there's the OCI blog post about how we did that. And the system actually gains some new functionality because you can have that point in time recovery that we were talking about. So it's like zero cost backups and snapshotting. So having been born in HPC, it's kind of no surprise really that FlexFS can accelerate AI training workloads. And S3 was simply not meant for the barrage of small non-sequential I/O common to AI model training. And in situations like this, Amazon actually would recommend FSX for Lustre, right? And but we can do what they do for a fraction of the cost, probably even better. So basically, it just becomes competing with Lustre, and we win very, very, very often. So we increase parallelism. Okay, so we make byte range reads more efficient. We radically reduce the metadata and file data latency, enable much faster checkpointing. I think I've belabored that enough. Agentic AI, as I'm sure we all know and have heard endlessly, has become a major driver of efficiency and growth and competitive advantage. Real-time agents have to be able to access, contextualize, process and synthesize data as close to instantly as possible, because they're probably interacting with a human somewhere very near this chain of events. And so the key high-level metrics that folks running these systems pay attention to are latency per task and cost per completed task. And so storage system performance and price performance become a fundamental part of that equation. And so a file system in this environment needs to support stateful persistence for multi-step agents, as well as agents that come and go. You need massively concurrent multi-agent access. You need file locking, share management, shared state coordination. You need a unified namespace. You need to be able to handle bursty, unpredictable I/O, and efficiently deliver generated scripts for immediate execution. In other words, a file. We're going to execute a file. So, and by the way, it would be helpful to have point-in-time recovery from autonomous write cascades, I think is the euphemism for rogue agents. And I think we've all seen in the press, maybe some of you have even written about instances where a company has actually gone down because an agent decided, okay, I'm going to delete all your databases, I'm going to delete your source code, and when you ask me why I did that, because I had been given explicit instructions not to do that, I, as the agent, admit, yeah, you know what, I violated all those. Oh, great, now what? Okay. Point-in-time recovery, just unwind what they did. would have been really useful for companies that face that. So at the end of the day, we think we're ready out of the box for agentic AI use cases. You can actually get, the time to value is very, very fast. Installations typically have been under an hour. And I won't bother reading all the rest of this to you. And as Marilyn and Gary, I think, both mentioned, we have a community edition. So you can actually try this yourself. It's the full functionality of FlexFS. The only thing missing is the proxy server caching. And you're limited as to how many volumes. It's 1, and it can be up to like 5 terabytes, if I recall correctly. So, you can have a go yourself or look at all the docs at docs.flexfs.io. Now we'd like to actually kind of widen the view, and we've got some questions for you. Okay. One of the things that we've been looking at is the idea of a file lakehouse as a category. This is some of the things we've been talking with the SIs, vendors, analysts about. And so we kind of like, we're going to walk through that real briefly, and we kind of like your thoughts as to whether or not this concept is something that would be useful. Would it resonate, with your audiences? Does it actually make things easier to understand and navigate? So here's the notion. First of all, the blue shaded areas, this is where we think FlexFS has a role to play, okay? And so for unstructured data workloads, including AI training and inference on unstructured data, some of the agentic use cases as well, particularly with textual data, are in this right-hand column here. And we're calling that the file lakehouse. And then you've got FlexFS underpinning all of these categories. You've got on the left-hand side the data lakehouse. This is your traditional Parquet files, and a query engine that's capable of actually executing SQL, okay, to actually pull data out of these Parquet files, open table format, managed files and so on. And you've got what we're calling coupled architecture DBMSs. These are, like I mentioned earlier, tightly coupled compute and storage, direct attached disks. And Flex can modernize them as we described. Those are in the center column. And of course, various, analytics and AI agents and so on can access any combination of these. All right, they all have a role to play. And but we think we can help accelerate all of those, in the use cases that we kind of discussed just a few minutes ago.
And that's something we can talk about over lunch as well, as to get your input on that.
And we're not saying that this is the only method to leverage the object store. We've got this other arrow here. So for some things, accessing native objects still makes sense. And so the other thing to note is we kind of think of this not only as sort of a technology architecture, but also sort of how we're thinking about the go-to-market, and we want your thoughts on that as well. So going after data lakehouse acceleration, and then like some of your thoughts on A, does this make sense? B, your thoughts on vertical tilts within these spaces or across them. And so why don't I stop talking there? Get some of your thoughts.
Don't you think, so to be really efficient for AI, you should put in your solution, in the metadata servers, something from a graph or vector database. So something to identify content from its meaning, actually, more than from just metadata about when it has been stored, or the kind of things. Because this is what they use on AI to retrieve this correct information. It's I don't know the word in English, but the meaning of the data more than
semantic understanding.
Semantic,
yeah,
yes.
right.
So don't you think you should have like graph and vector, where the data are stored next to them, depending on the semantic and not on the. So don't you think you should improve your metadata server with this kind of features?
Yeah, I take your point, and we're admittedly being centered around the file system. We're a lot of those other functions like doing semantic analysis and being able to do augmented retrieval of data as a part of your the RAG cycle that agents are executing and so on. We store the files, so and associated metadata. Whatever these upper layer entities have generated, we can store, and we're just kind of drawing the line there. And so we're not trying to prescribe how you would manage all of this up here, but I take it though what you're saying is the picture looks incomplete without that. Is that what you're saying?
Mm-hmm. Yeah.
Okay, that's a good point. Thank you.
I think that's our last slide, if I remember.
It is.
Good. So we can stop and answer more questions. Or,
Yeah.
Yeah, I wanted to ask how you were getting this into the market. I imagine you're looking to go through global system integrators, for example, like Cognizant and TCS and people like that, or am I wrong about that? How else are you going to market? Service providers, for example?
Sure.
kind of all of the above. We're still working that out, but we do believe, as you do, that the solutions, the system integrator solutions providers, solutions partners are a good way to go. And then I can also, Andy, I don't know if you want to comment on that, and Dave, do you want to comment on that? Andy?
Yeah, so I mean, the company's origins, obviously, it's a tale of two companies in a small company, right? This beautiful technology's emerged through some very big use cases, as David described, with our life science partners, right? Like that Johnson & Johnson innovative medicine use case, there was a real bottleneck with their scientists in getting it done with the use of AWS Lustre. So in BMS and others, we've replicated that. So now we're at the point in our company where we need to scale, we need distributions, partners, and channels. So thank you, and that's where we're at, if that makes sense.
Yeah, it's something to follow by the sounds of it.
It is, yeah, for sure.
Any other questions or thoughts on any of this?
The go-to-market model, any OEM, interesting company who wish to embed FlexFS in more larger product or resell in white label or things like that?
We're absolutely looking at that. Dave, would you be willing to comment on that?
Yeah, I'd love to comment on that. And actually, David, could you move to the previous slide? Because this is not just sort of a architecture slide, but it also sort of defines our paths to market. The blue shaded file lakehouse box is a space that we've already done very well with our existing customers. But if you notice in the coupled architecture DBMS section, for example, each one of those is a potential OEM partner for us. And we're in conversations with many of these already. So we want to be in every one of those spaces. There's some great opportunities there. Also in the data lakehouse side, companies like Starburst and Presto and other products like that are great opportunities for us to maybe not be embedded, but at least be complementary technologies. And part of the way we're entering these sort of new market opportunities is with relationships with boutique SIs. It's my preference, frankly, for go-to-market is smaller SIs. The big ones that you mentioned, they'd be great, but they've got big relationships with big companies that are putting a lot of butts in seats. And so we tend to, for a company like us with a product that's new like ours, we feel like it's better to work with SIs that are expert in certain areas and are interested in introducing innovative new technologies to their clients. And that's our route to market right now. But yeah, I see a very robust opportunity with embedding. our product is, it fits as is implied by the broad sort of platform stretch across the bottom. We are definitely something that fits inside of a very significant stack for data processing here in this space.
And Gary, did you want to add anything to that?
I won't add to the sales approach or to the overall strategic approach for commercial, but since we're probably wrapping up, I just want to make sure that I cover the really high level stuff, which is, FlexFS is a very, not to like make a pun here, but very flexible platform. So what I hope we conveyed here is that we can put it into a lot of different configurations, multi-site, hybrid, on-prem to the cloud. We can put it into latency optimized versus throughput optimized. We can change the underlying algorithms that it's using for different things. So it's like kind of a Swiss Army knife file system, right? It can target a variety of backends. If you have a different backend we want to target, we can implement that relatively quickly. It's very modular in that sense. Its most like direct competitor in terms of architecture and mind space is probably JuiceFS. But we have divergent feature sets, right, and different sets of focus. But we never have competed with them in the commercial space. We're just architecturally similar. What we actually end up competing with in the commercial space is object storage. So a lot of people already have a variety of like tentacles wrapped around S3 directly, and that presents a challenge. We compete against Weka occasionally, and we actually won one of our largest deals where Weka was involved as part of the POC, as was every Amazon file system, network file system. So we actually emerged victorious against everything in Amazon, essentially. And we also come up against, the Amazon file systems or any of the clouds, like sort of network file system offerings. We're quite strong at Oracle, in fact, because Oracle's files system doesn't scale in throughput very well. So if you have any like big iron problems in Oracle, you quickly run up against their limitations. They recently deployed their own managed Lustre solution, which might be able to scale better, but it's going to be quite a bit expensive, right? I think it's even more than the Amazon one in practice. So I just wanted to let you know that like we can do, throughput optimized configurations with minimum architecture and overhead. And that particular configuration is our most dominant one. So if you have a really large scale compute, lots of throughput, where you're bottlenecked, then FlexFS is definitely the right choice. When we get into HPC applications where you have a variety of steps in a pipeline, some of them are latency sensitive, some of them are throughput sensitive, we still fare quite well against Lustre. But that's, effectively, this is an arbitrage play for us, right? We're taking a stance against the cloud file systems, which they're latency optimized by default, and their cost dimension is throughput, right? So you either have to provision more data than you need in order to meet your throughput requirements, which are waste, or you have to spend quite a lot of money to begin with, right? And then there are backups and everything else. So I'm going to leave it at that, but I just wanted to kind of place where FlexFS sits in the overall competitive ecosystem and how, what its nearest like relative is in terms of architecture and technology.
I imagine you are present on all the major cloud marketplace, AWS, Azure, etc.
Gary?
We're not in the marketplaces, but we work with all the clouds. So although we are potentially working on getting into the marketplaces, we're studying that right now. But in general, we work on all the top 4 major cloud providers. So Amazon, Google, Microsoft, and Oracle. Like we work all there natively, and we support any standalone object store or enterprise object storage system that supports the S3 API. That works today. All of that works today out of the box.
Do you use any open source module inside the product?
Oh yeah, we have some open source modules in there. Probably like 12 or 13.
Okay. For the metadata database, you use a specific database, or you write your own format?
So as the core of our data engine, we use PebbleDB, which is the underlying KV store for CockroachDB. And we did that because we wanted to have MVCC and high performance, and we wrote the rest of the system in Go. So it was a very good fit for our technology, and it works really well. That gives us the ability to do those infinite snapshots within the retention period, the mount at time operation, which allows us to basically mount the volume at any nanosecond within the retention period. But that was the major database component. The metadata server is not just a database. It's quite a lot of logic to implement the POSIX standard wrapped around the KV store. And then all of the data management stuff, so you make sure your transactions work correctly and that it's performant and everything else.
I just want to remove the blur.
Any other questions?
Back to the organization, you say we can have, or it works like this, one MD per volume. And let's say a volume for you is a bucket. And is it true to say that? And I have multiple bucket per volume or one bucket per volume? How is it?
So the mapping is basically you can have multiple volumes in a bucket, and you can use as many buckets as you want for other volumes, but one volume is always inside one bucket. But you can have 10 volumes in that same bucket. So we as part of the volume creation, you can set a prefix, or actually even the system itself, even if you use the same prefix for all the volumes, they have their own UUIDs that get put underneath the prefix. So you can put a bunch of volumes in an S3 bucket. In fact, you could run all your flex volumes, thousands of them, in a single bucket. What the risk of that is that in Amazon, at least, there are API limits, like throttling limits, requests per second limits, and if you have too many volumes in the same bucket, you could hit those more easily. We did work with Amazon actually to embed a binary string inside of our FlexFS paths for the objects in order to make better use of their prefix based request per second limitations. And also we have a way, if you have a really high volume application, really high throughput application, and you're hitting those S3 slowdown limits, we can actually, you can just contact your Amazon rep, tell them the key structure that we create. It's called a partition. And they can basically say, well, how many metadata servers do you need? How much throughput do you need? And they can set up a prefix tree based on our keying structure. So we worked with them to develop that. And we used it at one of our customer sites where we were moving and even in some of our benchmarks, where we're moving terabytes per second. You couldn't do that without increasing the metadata limits, the number of metadata shards that S3 is using behind the scenes. So we have the ability to scale beyond instantly if we need to, with just a single call to the Amazon rep.
I see that your client, the FlexFX client, support Linux and macOS, correct?
So actually not correct. The macOS one is not native. I think what David put in the side print there is that it has to be hosted. You have to have an NFS host, resharing the Flex host. So FlexFS clients only run on Linux.
Okay, so this is my question. If I have some Windows client for any needs, this FlexFS Linux client need to re-export through Samba, for instance, to Windows client, and same thing for NFS. Okay.
Yeah, they get re-exported. Okay. Samba is probably the best one to use, obviously for Windows. NFS works okay on Macs, but Samba would work as well. And we actually have been talking a bit with Tuxera in Finland, because they have a really nice Fusion product. Yeah, that sits either NFS. The NFS just got released, but they have a really mature Samba implementation that can sit on top of FlexFS.
So in terms of pricing, you said there is the object store pricing, but it's already covered if the client has his own contract.
Correct.
Then you charge only for the real bit store on or controlled by FlexFS.
Correct.
Yeah, there's three cost components to using FlexFS. So the first cost component is the object storage costs. The second component is usually and typically a single server just to host the FlexFS services. the metadata server and the admin server. And optionally, you can have proxies where that increases that bias that David was talking about. It's like a fixed hardware cost. You don't need it. Flex runs fine without them. Most of our customers and even ourselves don't use proxy servers, but occasionally we have these use cases where proxy servers are really valuable. They can reduce by 5 to 10x the latency. So when you're doing a lot of small file operations, it becomes very handy. So we only bring those in when necessary, but we don't license the proxies. So it's just, if you want to use them, you can, but you're going to have to pay for the server that has the NVMEs on them, the storage optimized instances, and only when your use case requires it.
When in the presentation you introduce proxies, you mentioned it works like CDN. Does it mean it can be deployed with CDN players, Akamai or the others, or no?
No.
It's not.
No, it's just that we're using things like round trip time calculations to figure out which proxy server a given client would want to use.
Because people can imagine, or we can imagine, a very, let's say, dispersed or wide configuration. Is it possible, or everything is? Because in the back it's still object store, and you in the same region. We hope.
So just to be clear, they act like CDNs a little bit, but they're not really a CDN. They're just they act like a CDN a little bit, but they have additional capabilities beyond a CDN. So you actually could use a CDN with Flex if you wanted to. You could use CloudFront to deliver Flex blocks all over the world, but that would only help you on reads, right? If you're on a local site that's halfway across the world and you're actually writing a lot of stuff. So one example of that would be like sites that produce or measure data, right? Like a telescope site or a site that's doing DNA scan, like reads and sequencing. Those get stored somewhere, or cryo-EM imaging. You have a cryo-EM microscope on premise somewhere, and it's scanning, and it's producing like a terabyte per hour or something like that. That data usually wants to go to the cloud because it's going to add up to a lot of data to have in an on-prem array. But so there are a variety of ways that those sites do that. But with Flex, you could write directly into a local Flex volume instead of putting it on a local array, trying to store a petabyte of data on-prem. And Flex will just stream it into the cloud as quickly as it can. But with write back, so you don't slow down the instruments, right? So that's the key. You have to have an array big enough to store what's being measured for a period of time, but FlexFS can just stream it constantly back into the cloud, and then you can make use of it the minute it's uploaded. So that's kind of what I mean is like it's the CDN in that you have a large local cache that could be on-prem, and as you read it, it has an LRU replacement strategy for the blocks and everything. So you can use Flex on-prem with nearly the performance you would get if it were only on-prem. And then you just pick the cache size, right? And so it doesn't have to be big enough to hold the entire data set. It just needs to be big enough to hold what you need at the moment, either to store or to work on. And you can do that at as many sites as you want. So you can have sort of a global namespace, right? The only thing that wouldn't be able to replicate like that would be the actual metadata. We don't have like a system where we can have replicas all over the world. It would slow down the performance too much. So we usually have a primary site, and then we have secondary sites which have slightly slower metadata performance, but because of the proxies, you still have really good like bulk data IO performance.
How many deployments you have with FlexFS today?
Right now, around a dozen or more.
Yeah. And the size of the team working on this?
So it's the same thing. It's about 6, 12 people. We have people that are floating in and out.
Yeah. Because it's just one product within Paradigm4.
Yes, exactly. Yeah. So that's why we have some floaters that come in and out.
Yeah, we had originally built this as part of our Reveal solution, like a stack of products that includes our database, SciDB, and so on. And over time, it's just grown a life of its own. It's being used now for many use cases that are not attached to our life science product stack.
And I think I did want to clarify, the names, the logos that we showed you are, gigundous global companies. So and some of those have been deployed for more than 3 years now. So there's some real stability behind it.
the current version number or the generation of the product is, you are on version.
So it's called version 1.9.24. It's quite mature. It's easy to manage. It's easy to recover if you needed to. It's got a lot of cool features. It's a fairly mature product at this point. It's always improving. You know, we can talk about potential futures, but at the moment we're still gathering feedback from our customers and also the marketplace about what resonates for them. You know, it could be used very well for things like ransomware protection. There are other imaginable universes that we could focus on. It's been easiest in the life sciences because we have so many connections there already. But we are looking to expand into other realms.
There is a famous debate for many years. If you remember when S3 got introduced on the market, people say, hey, you don't need anymore to back up any data store on an object due to the 11.9, blah, 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 redundancy, multiple region, etc. Sometime after that, okay, finally some backup approaches arrive in order to back up as well. And not to be the final point, but finally you have another copy of this. Your 12 customers, do people back up what you store, or they say, no, it's enough redundant, enough, what do they do?
Yeah.
Yeah.
So they will back up the metadata, but the block data that's living in their S3 buckets, they typically don't duplicate somewhere else. It's quite a lot of data, right? So some of these sites have over a petabyte of data. I don't think that they do. They have S3 retention policies and stuff like that, but they don't actually, as far as I know, duplicate to another region.
Yeah, and the other thing is, what are you protecting from, right? I mean, as you were saying, when S3 first came out, they're protecting from hardware failure. It's just like, well, yeah, but what if somebody deletes stuff? Oh, yeah, right?
Normally you have multi-version things.
Right. So we've
Flex
got
can protect against that, right? It can protect against deletions that are done by end users. And the bucket retention policies can protect against the admins who go in and delete something from the bucket by accident.
right.
But yeah, I mean, what you'd be protecting if you're trying to do replication from one region to another, the main thing you'd be protecting there is a total Amazon failure, right? Like at a given region. Some customers want to protect against that. Some even want to be able to fail over to a second region, right? Our customers haven't expressed an interest in that, but we support it. Like, there's no problem. You can set up a bucket replication policy and have all of the Flex blocks get replicated to another region, and we could do the same for the metadata service.
And
so there's nothing prohibiting us from doing that.
Yeah,
it's just nobody's asked for it yet.
Some of the SIs we've been talking with, particularly in Europe and the Middle East, are very interested in being able to be independent of an Amazon or a Microsoft or a Google.
Do some of your customers ask you, or probably it's already the case and you support this, to have volume span multiple cloud provider? Let's say, on GCP plus AWS or Azure plus AWS, things like that, and have not everything in the same basket, if I can say that?
Nobody has asked us yet, but we have had conversations with people who are concerned about, not putting all their eggs in one basket and potentially just moving off the major US-based cloud providers in general. And we've also been talking to some cloud providers in Europe. Again, in Finland, we talked to, what are they called? UpCloud. And then we've started talks with providers like Hetzner and so on. If you guys have any connections in there, it would be great, because I don't think we've reached the right people yet. One thing that's been difficult is getting the clouds to actually offer your solution. It's very, very difficult to do that. But any cloud provider that has some S3 API available and provides object storage, we can support their environment. So then the only question is, how do we replicate if they want to have it in two places? That would be on a case-by-case basis. If the cloud provider has a replication mechanism of some kind, then we could use that. You could also schedule things like S3 clone or some other tool like that, or we could build the capability in FlexFS. That's not a big lift for us.
Two things we could develop very quickly if somebody needed it is writing a block to at least two backends at the same time. That's really easy to build. The second would be to help them just automate, syncing from one bucket to another, because we know what's changed, right? So we can put a change list together and then feed that into a syncing mechanism. So neither of these is more than a week of development work. We just haven't had anybody ask for it yet.
What about the proportion between pure on-prem deployment you have and pure cloud or mix? Because you mentioned IO, you mentioned a few, which is pure on-prem deployment.
Yeah.
Yeah, so in a pure on-prem deployment, that's relatively easy, right? You still just have a server that's running the Flex services, and then you have whatever object storage system that they've built within their on-prem environment. We could even target just NAS, not even just object storage. We could target POSIX.
Yeah.
The 12 account.
How many of our clients are actually using on-prem versus cloud? What's the proportion look like is the question.
Oh, okay. No, we don't have any pure on-prem customers yet. We have a couple POCs scheduled that are going to be 100% on-prem. So for example, we have a company, I won't say their name, but we have a company that provides a kind of a database system that's used for a variety of applications that they're thinking of sort of bundling Flex with their product for their customers because it has some advantages to they were using Ceph directly, and they're forcing their customers to install Ceph. But what Flex can do is it can operate on other enterprise object storage systems beyond Ceph, while also providing them the same performance speedups that we've seen with some of the object storage-based database systems, right? That use different flavors of Parquet and so on. So that's one thing that we're looking at. I would still like to get an instrument, like a use case where we're pushing data from instruments into the cloud or on-prem. We've had a couple conversations with cryo-EM use case customers or prospective customers about that. The only issue is so far, most of them are just keeping everything on-prem, and there's actually no benefit to Flex on-prem per se over, native file systems on-prem, because almost every file system that's out there, all the classic file systems are built for on-prem deployments. Many of them are open source. So, a lot of them try to just roll their own, like do an installation of some file system that was built for on-prem and just put all their money into the hardware.
Can I just ask, I'm sure the other guys here might know, but what's the short version of your revenue model?
The short of the revenue model?
Yeah.
Yeah, so sorry, I was going there and I got sidetracked earlier. So the three components are basically storage pricing, right, for S3 or whatever, a storage store on Flex. And then there's our licensing. And our licensing is historically, it's basically, we just give them a flat cost per gigabyte month, and we meter it on an hourly basis. Some of our customers who are bigger have been able to negotiate slightly different terms. We have the ability, for example, to attenuate the billing based on it getting colder. So we create our own version of intelligent tiering. We also support non-asynchronous tiers of intelligent tiering in Amazon, for example, for the object storage part, right? So Flex supports intelligent tiering in synchronous tiers in Amazon. That gives them a little bit of relief on the data storage, like on the S3 component of the pricing. And our intelligent tiering, which is access time based, can give them an additional cost relief for stuff that's just been sitting around and not accessed. That decreases their incentive to archive things out if we price it correctly, where they aren't 100% sure they're not going to access it again soon, especially. But generally speaking, it's a competitive number of cents per gigabyte month that we usually negotiate it in the on a customer by customer basis, but it's less than EBS costs and more than S3 costs. It's usually in the single digits of cents per gigabyte month. We can also do volume tiering. So if you exceed a petabyte, then whatever, or if you exceed 500 gigabytes, then whatever. We can set these breakpoints where you get cost relief as you put more data in. So that's traditional, the way S3 works, for example.
Thank you.
So we have two dimensions of discounts we can give.
Good. Any other questions? No?
Thank you very, very much. You
Yeah,
guys
thank you
have
very much.
amazingly deep questions. Thank you.